Hello and welcome back. For this video, we're going to show how to solve systems by elimination, and we're going to do that elimination using addition and subtraction. Of course, when you look at the goals, you can see solve eliminating using addition and solve eliminating a variable using, and that should say subtraction. Okay, for our first example here, elimination using addition. Now, when we do elimination, what we look for is the coefficients. So coefficients of x and the coefficients of y. We're looking for coefficients that have the same number with opposite signs. And you can see that we have the 5y and the negative 5y are opposites. So the way that we're going to eliminate y is to simply add the two equations together. So 3x plus 5x gives us 8x. Now, if I were to take the 5y and add a negative 5y, what I would get is 0y, which drops out of the problem. Bring down the equal sign, and then 11 plus 5 is going to give me 16. Keep solving for x. X equals 2. Now, remember, we have two solutions here. So the first one is 2. And the way that we solve for the other one, the y value, is to go back to one of our original equations and substitute a 2 back in for x. I'm going to go to this top one right here and substitute in there. So that would be 3 times, and in place of x, I'm going to put 2. So that 2 is going to go there. Plus 5y equals 11. And just keep solving. So 3 times 2 is 6. Plus 5y equals 11. Subtract 6 from both sides. So 5y equals 5. Y ends up equaling 1. And there's our solution using addition. Okay, for our next example here, we'll notice that the x values over here have a 5 and a negative 5, so I can eliminate them by adding together the two equations. So add together, 5 plus negative 5 is 0x, that drops out of the problem. And then the 13y plus the negative 3y is going to give us a 10y, that's going to equal. And then over here we have 20 plus 30, which is 50. When we divide out here by 10, y ends up equaling 5. So half of our solution is 5. Now I got to find the other half. And I'm going to choose to take this 5 right here and substitute it into this equation. So negative 5x minus 3 times, and in place of y, I'm going to put 5. And it's still equal to 30, and keep solving. So negative 5x, this right here will give me negative or minus 15 equals 30. Then I'm going to add 15 to both sides. So I have negative 5x equals, when I add 15 to 30, I get 45. And then divide both sides by negative 5, and x equals negative 9. So the solution to this system is negative 9, 5. All right, and the next example wants to write and solve a system of equations using addition. So I have to write it first, then solve using addition. Okay, so it says 7 times a number minus 4 times another number is 13. Negative 7 times a number plus 7 times another number is 14. Find the numbers. So the first thing I need to do here is identify the numbers. So let's say A equals first number and B equals second number. And you need to get in the habit of identifying your variables. Then I come back up here, it says 7 times a number. So let's call that the first number. So 7 times the first number minus 4 times another number. So minus 4 times the second number we'll call B means equals 13. So there's our first equation. And then negative 7 times a number, so that's that same number again, so negative 7 times A, plus 7 times another number, plus 7 times that second number is 14. Now when I look at these, you'll see that the A's have the same numbers, or the opposite coefficients, so we're going to eliminate them by adding. So when I add those together, I get 0A, which drops out of the problem. Over here I have a negative 4b plus 7b, which is going to leave me with 3b, and that's going to equal, then 13 plus 14 is going to leave me with 27. When I keep dividing, b ends up equaling 9. So the first number is, actually that's the second number. The second number is 9. Now to find the first number, I have to substitute this 9 back in somewhere. And I'm going to substitute it back in right here into that first equation. So 7a minus 4 times, and in place of b, I'm going to put 9 equals 13. So 7a minus 36 is going to equal 13. And then add 36 to both sides. 7a equals 49. And divide both sides by 7. A equals 7. So the numbers are 7 and 9. Those are the two numbers that they were talking about. For our next example, we're going to use elimination using subtraction. Now, the reason we'd use subtraction is we have coefficients of variables that are the same number but not opposite signs. So, for example, if you look at the 6's right here, they're the same coefficient, but they're not the opposite sign. So adding them together will give us 12y instead of 0. So the way that we get them to eliminate is instead of adding, we will subtract. So we put a subtraction out, and you have to be careful on this. We start with the first one, which is 3x. We say subtract 5x, and that will leave us with a negative 2x. Then, of course, 6y minus 6y will give you 0y, which eliminates from the problem. Bring down the equal sign. And then we come back and we say 30 minus 6 is 24. We keep solving, divide by negative 2, x equals negative 12. So half of our answer is negative 12 for x. In order to solve for y, we still have to go back to one of the original problems. Since the coefficient of this one is only 3 instead of 5, I'm going to substitute my negative 12 in place of that x. So 3 times negative 12 plus 6y will equal 30. And then keep calculating. So this is going to give me negative 36 plus 6 is equal to 30. Add 36 to both sides. So 6y is going to equal 66. Divide both sides by 6. Y equals 11. So the solution is negative 12, 11. Okay, we're going to try this again. So when we look at these two, you'll notice the y's have 3's, but they're the same sign. In order to get same signs to cancel, we need to subtract. Remember, we're trying to eliminate either the x or the y. So when we go to eliminate here, we're going to subtract. So we have negative 2x minus 7x. Is that going to give us negative 9x? And of course, 3y minus 3y is 0y. So the y's drop out of the problem. Bring down your equal sign. And then don't forget to subtract on this side. So 48 minus 21, and that's going to give us 27. Divide both sides by negative 9. X ends up equaling a negative 3. So half the answer is negative 3. We got to find the y value. And I think I'm going to substitute my x into the second equation right here. So 7 times negative 3 plus 3y equals 21. So negative 21 plus 3y equals 21. Add 21 to both sides. 3y ends up equaling 42. Divide both sides by 3, and y equals 14. So the second part of the solution is 14. The whole solution is negative 3, 14. All right, for our last example, they want us to write and solve a system, but they want us to use subtraction through elimination, or elimination through subtraction. Okay, so that's what this says here. It says, May and Kara build computers from parts and sell them to make a profit. May can build a computer in 0.9 hours. So that means she takes 0.9 hours per one computer like that. Kara can build one in 1.2 hours. So she's got 1.2 hours per one computer as well. That's for Kara. So this is May and this is Kara. During a typical week, May and Kara spend a total of 15 hours. In one particular week, May builds twice as many computers, and the two spend 24 hours on their project. How many computers do May and Kara each make during a typical week? So this is during a typical week, so it's how many computers. So I'm going to define M equals the number of computers May builds, and this is in a typical week. I'm not going to write it down, but that's what that stands for. And then let K equal number of computers Kara builds. And this is also going to be in a typical week. So both of these variables are in typical week. Now I see two pieces of information here. I see a total of 15 hours and a total of 24. So I'm going to start with the 15 because that's a typical week. 15 hours is equal to now I've got hours on this side, so I got hours here, so I got to get hours plus hours over here as well. Well, the way I'm going to get hours plus hours is I got to turn M, which is number of computers, into hours. So remember up here when I wrote the ratio or the rate at which May is building, she's building 0.9 hours per one computer. So if M is a computer, these computers will cancel out when I multiply, leaving hours left over. So the number of hours she spends during that 15 hours a week is 0.9 times M. Plus I have to add in Kara's, and hers was only 1.2 or 1.2 times K. So that's the first equation there. The second one talks about 24 hours. So I got another 24 total. The only change I'm going to make here is that it says, where does it say? Right here. It says, I'm sorry, not right there. It says May builds twice as many computers during that 24-hour week. So up here where we had 0.9, I want to double that and call it 1.8. So that's going to be 1.8 times M plus 1.2 for Kara, because Kara was just working at her typical pace. Now we are going to subtract these to solve, and the reason we're going to subtract them is because over here on the K, we see they have the same coefficient. That's what we're looking for, and they have the same sign, so in order to cancel them or eliminate them, we have to subtract. So I'm going to go ahead and subtract. So 15 minus 24, and that's going to give me negative 9. And that's going to equal 0.9 minus 1.8, and that's going to give me negative 0.9 M. And the only thing I have to do here is divide both sides by negative 0.9 to get the number of computers that May builds. So May is equal to 10. So that's about 10 computers in a typical week. And then as far as Kara is concerned, all I got to do is take this 10 and substitute it back into one of my original equations. Now, the easier of the two equations appears to be this one up top because it's got smaller numbers. So I'm going to substitute 10 in place of M. So 15 is going to equal 0.9 times 10 plus 1.2 K. Start simplifying this, and I have 15 equals 9 plus 1.2 K. Subtract 9 from both sides, and I get 6 equal to 1.2 K. And then I want to divide both sides by 1.2, and that will give me K equal to 5. So remember, this is in a typical week. In a typical week, May builds 10 computers, and Kara builds 15 computers.